Hi everyone, my name is A. Umashiva Nagaprasad, working as an assistant professor in Sri Vasavi Engineering College, Tadepalligudem, West Godavari district, Andhra Pradesh. Today now I am going to discuss the topic is series circuit, parallel circuit and series parallel circuit. Why? Because many of the students are still not recognizing or getting confusing in between the differences between series circuit and parallel circuit. So therefore, I'm going to discuss the today's session, that is series. First of all, series circuit. So first of all, what is meant by circuit? Interconnection of various elements. It is called as circuit. So those various elements are classified into mainly active and passive. So active elements or active sources, which includes voltage source, current source, battery, so on so. Whereas passive elements, which includes resistance, inductance and capacitance. So these are called as passive elements. So interconnection of active and passive elements forms a circuit. So in this, now we are going to discuss series circuit. So interconnection of this voltage source and resistances I am connecting here. So V is a voltage source and resistances R1, R2 and R3. So these three resistances are connected in series with respect to voltage source. So voltage source, it is a active, whereas R1, R2, R3 resistances are called as passive elements. So interconnection of active and passive elements forms a circuit. So now this is a series circuit. So how we are classifying whether it is a series or parallel? Let me say so R1 is a resistance which is having first end and second end. So if I am connecting one more resistance R2, that is, so the end point of first resistance is second end. So the next resistance which is starting at the second end forms a series circuit. I mean series. Whereas parallel means, so this is the first end and this is the second end. So parallel means I am connecting one more resistance R2, that is, if the first end is connected to first end of resistance R1 is connected to first end of R2 resistance. Similarly, second end of R1 resistance is connected to the second end of R2 resistance, then it forms a parallel. So in this way, we have to recognize either the resistance is connected in series or in parallel. Let me say once again, I am repeating the point. Series means R1 has two ends, first end and second end. If the second resistance I am connecting to the second end of R1, that means R2 is starting at first end, whereas R1 is second end. So likewise, then we can say it is series. Whereas parallel means, so R1 has two ends, 1 and 2. Similarly, R2 also has 1 and 2 ends. So whenever the first end of R1 is connected to first end of R2, second end of R1 is connected to second end of R2, then we can say those two are connected in parallel. So this is the main difference between series and parallel circuit. And one more point is in series circuit, the current flow is same. In series circuit, the current which is flowing in series circuit, then it is current will be same. Whereas in parallel, the current will be dividing. The current will be divided in parallel, I1 and I2. So this is the main difference. So current flow in series circuit will be same in series circuit. Whereas in parallel circuit, current will be divided into I1 and I2. Total current I is dividing into I1 and I2 in parallel circuit. So this is the main difference between series and parallel circuits. Let me explain with an example. So in this circuit, so V is the voltage source, current I is flowing in this entire circuit will be same. Why? Because it is a series circuit. See, R1 is connected and the second end of R1 which is connected to first end of R2. Similarly, R3 also. So continuously we are connecting the resistances R1, R2 and R3. So which forms is a series circuit. Now let me solve let me explain with one example. Yeah, for example, okay, voltage is, for example, it's say 10 volts. R1 is 1 ohm, R2 is 2 ohm, R3 is 2 ohm. So these are the three resistances having the resistances 1 ohm, 2 ohm and again 2 ohm. And the voltage source he has mentioned, I mentioned is 10 volts. So how much current is flowing in the circuit? So first of all, this is a series circuit. Why? Because already we discussed all the resistances are connected in series. So therefore, first of all, you have to calculate R equivalent. So in series circuit, R equivalent means you have to add all the resistances. Therefore, R equivalent becomes R1 plus R2 plus R3. So which is equal to R1 is 1 ohm, R2 and R3 are 2 ohms. Totally R equivalent becomes 5 ohms. 2 plus 2, 4, 4 plus 1, 5 ohms. So R equivalent is 5 ohms. And we know the voltage source is 10 volts. So according to Ohm's law, the relation between voltage and current is V is directly proportional to I. So from this V is equal to Ri or IR, whatever it is. So from this we have to calculate current I. Why? Because you have to find the current I. Why? Because voltage source was given and the resistance is also mentioned. So from this I is equal to V by R equivalent. We have to say it is R equivalent. So we calculate all the resistances, therefore it becomes R equivalent. Therefore V by R equivalent is equal to I. So which is equal to V. V means voltage source, he has mentioned, that is 10 volts by R equivalent is 5 ohms. So 10 volts by 5 ohms. So which is equal to current, that is 2 amperes. So the value of I is 2 amperes. So the current flowing here is 2 amperes. The same 2 amperes current is flowing in the resistance R1, R2 and R3. The same current. For example, if the question they mentioned, what is the current flowing in R2 resistance? What is the current flowing in R2 resistance? 2 amperes. Why? Because the circuit is series circuit. Therefore, the same current will be flown in the entire circuit. So, I is 2 amperes flowing in R1, same 2 amperes flowing in R2 and same current flowing in R3. That is 2 amperes. So, same current is flowing in the entire circuit. So, current will be same. Then what about voltage drop? Total voltage is 10 volts. But in series circuit, voltage drop takes place. So in this R1 resistance, the voltage drop takes place is V1, whereas in R2 is V2 and in R3 is V3. So this is the voltage drop takes place in series circuit. Current will be same, whereas voltage will be divided. So in series circuit, voltage drop takes place. So the algebraic sum of voltage and algebraic sum of voltage drops in a closed circuit or in a closed loop is equal to 0 according to Kirchhoff's voltage law, KVL, according to KVL. So that is V is equal to V1 plus V2 plus V3. Or you can say V minus V1 minus V2 minus V3 is equal to 0. So according to Kirchhoff's voltage law. So V means here voltage source. So which is equal to sum of voltage drops. So how many voltage drops takes place? Totally 3 voltage drops are there as per the given circuit. 3 resistances, therefore 3 voltage drop took place. What are those? V1, V2 and V3. So if you add these 3 voltage drops, it must be equal to given voltage source V. So therefore let me check whether we are getting the same or not. So let's see, 10 volts is the voltage source. Then what is the voltage drop V1 in this R1 resistance? So V1 is equal to, according to Ohm's law only, so V is equal to Ri. So from this V1 is equal to R1 into I. So V1 voltage drop in resistance R1. So V1 is equal to R1 into I. Current flowing in resistance R1 is I. So V1 is equal to R1 into I. So which is equal to R1 means 1 ohm into current is 2. So it is 2 volts. So this is 2 volts. So voltage drop took place in R1 resistance is 2 volts voltage drop. Similarly for V2. So V2 is equal to, so R2 into I. So R2 value is 2 ohms, current I is 2, it is 4 volts. So V2 is 4 volts. Then what about V3? So same formula. Why? Because the value is same. R2 is 2 ohms, R3 also 2 ohms and current is 2 ohms. Therefore automatically you will get V3 also 4 volts. Otherwise you can solve. V3 is equal to R3 into I. So R3 value is 2 and current I is 2. So it is 4 volts. V3 is 4 volts. So let me check the condition. So V is equal to V1 plus V2 plus V3. So V means voltage source is 10 volts is equal to V1 is 2 volts. 2 volts plus V2 4 volts, V3 also 4 volts. So 4 volts plus 4 volts. So which is equal to, so 4 plus 4 8, 8 plus 2 10. So 10 volts is equal to 10 volts. Or otherwise based upon this condition, 10 volts, V is 10 volts, minus 2, minus 4, minus 8, minus 4. So 4, 4, 8, 8 plus 2, 10. So 10 volts minus 10 volts is equal to 0. Or 10 volts is equal to 10 volts according to Kirchhoff's voltage law. Hence the condition was satisfied. So from this what we are getting the point is, in series circuit current flowing in the series circuit is same, whereas voltage drop takes place in the series circuit. Whereas in parallel circuit voltage will be constant. In parallel circuit voltage will be constant, whereas current will be divided, means current drop takes place in parallel circuit. So let's discuss parallel circuit now. So this is the example how we solved the series circuit. Now let's discuss parallel circuit. So parallel circuit, so voltage source, see here I am drawing the resistances in parallel. See, V is the voltage source and resistances R1, R2 and R3. How they are connected? The first end of R1 is connected to first end of R2. other end of R1 or second end of R1 is connected to second end of R2. Similarly, the first end of R2 is connected to first end of R3, and second end of R2 was connected to second end of R3. So if this connection was took place, then we can say it is the resistances are connected in parallel connection. And in this case, the current I, total current is I, thereby in this parallel circuit, the current will be divided or current drop takes place in parallel circuit. I as I1, I2 and I3. So in this way, the current drop takes place. Why? Because in parallel circuit, voltage will be constant. Let me say example. All the domestic loads are connected in parallel to the voltage source. For example, if you switch on any light or fan or any domestic appliances, it will get the voltage supply is 230 volts. So that means all the loads are connected in parallel to the supply. So if you switch on any domestic appliances, it will get 230 volts. So how it is getting 230 volts? Why? Because the source we are applying is 230 volts. So all the loads which are connected in parallel to the voltage source will be applicable, that all the loads will get the same 230 volt supply. Therefore, all the domestic loads are connected in parallel connection to the supply. So that's the meaning. Okay, anyway, we'll discuss the problem. For example, here also I am taking around 9 volts or 10 volts. Okay, R1, 1 ohm, 3 ohm, and R3 is 6 ohm. So in this problem also we are going to calculate total current, and similarly the current drops I1, I2 and I3. So first of all, if the resistances are connected in parallel, so we have to check, the formula for R equivalent. If the resistance are connected in parallel, we have to use the formula for R equivalent is R1 R2 by R1 plus R2. So with this we are able to solve the R equivalent. So R equivalent is R1 R2 by R1 plus R2. For first two resistances we are calculating by applying the formula of parallel resistance, that is R equivalent is R1 R2 by R1 plus R2. So R1 value is 1 into 3, R2 is 3, divided by R1 plus R2, that is 1 plus 3. It is 3 by 4. So 3 by 4 ohms is the R equivalent. Whereas, so 3 by 4 is the R equivalent for these two resistances. So apply this to again, that means the circuit will be modified as so R1 and R2 combination was took place by replacing with R equivalent, that is 3 by 4 ohms, and the next resistance is 6 ohms, the current here I. So by applying the same formula again, R equivalent is R1 R2 by R1 plus R2. This is the first resistance and this is second resistance which are connected in parallel. So therefore 3 by 4 into 6 by 3 by 4 plus 6. It is 18 by 4, and here if you take so it is 3 and 1 4 is 24, so it becomes 18 by 4 by 27 by 4. So 4 gets cancelled, otherwise you can say 4 by 27, 3 6, 3 9s, 3 2s, 3 3s. So totally R equivalent becomes 2 by 3 ohms. Totally the value becomes total equivalent resistance after simplifying, you will get 2 by 3 ohms. So the circuit will be modified as now so voltage is 9 volts, the R equivalent is 2 by 3 ohms. So from this current, according to Ohm's law, we know the formula V is directly proportional to I. So from this, V is equal to Ri. So I is equal to V by R equivalent. V means 9 volts by R equivalent is 2 by 3 ohms. So from this you will get the current 9 volts by 2 by 3. So this is the okay, whatever it is, amps. Total current is, so this much of current is flowing in total current in parallel circuit. Otherwise we can discuss with a best example or simple example. Let me discuss with one more problem. So this is total current. So thereafter we will calculate individual currents I1, I2 and I3 based upon those resistances. And one more technique to discuss the parallel circuit is, suppose the resistances are connected in parallel is of the same value, for example, let's say it is 10 volts, okay, whatever it is, R1, R2 and R3. In parallel resistances, if any of the resistance, if the two resistances are having the same value, then the R equivalent becomes R by 2. For example, voltage source, two resistances are connected in parallel, which is having the resistance value is 2. For these two parallel resistances, these two are connected in parallel, of course, and the value is same, 2 ohms, 2 ohms. So in this, for this circuit, we can easily calculate the R equivalent by direct technique, that is R equivalent is R by 2. So by applying the formula without using the by calculating the formula R1 R2 by R1 plus R2. So by using this formula also you can calculate the value. So instead of using this formula, directly you can apply the formula R equivalent is R by 2. If the value is same, the parallel resistances having the same value, then you can apply this formula directly. So R by 2, that is 2 by 2, it is 1 ohm. 1 ohm. So in this way we are able to solve the problem directly by applying this technique. But the parallel resistances having the value must be same. Let me discuss with a small example. Yeah. Yeah, 10 volts is the voltage source and R1, R2, okay. So R1 value is 2 ohms, R2 is also 2 ohms. This is the total current I. The total current I is dividing into I1 and I2. Why? Because these two resistors are connected in parallel. Therefore, the current will be divided and voltage across R1 and R2 will be same. Why? Because in parallel circuit voltage will be same, whereas current will be divided, or current drop takes place in parallel resistances. So R1 value is 2, R2 value is 2. So just now we discussed by using the technique R equivalent is R by 2. So R value is 2 ohms. So 2 by 2 it is 1 ohm. So R equivalent is 1 ohm. So from this, according to Ohm's law, V is equal to Ri. So I is equal to V 10 volts by R equivalent, that is 10 by R equivalent 1 ohm, it is 10 amperes. So R equivalent is 1 ohm. So according to Ohm's law, V is equal to Ri, I is equal to V by R equivalent. V means 10 volts and R equivalent is 1 ohm. So 10 by 1, it is 10 amperes. So total current is 10 amperes. So how can you calculate I1 and I2? So same from the same relation of Ohm's law. So we know V is equal to Ri. So from this, V is equal to R1 into I1. So we are calculating I1. So I1 is equal to V by R1. V is 10 volts, R1 is 2 ohms. So V is 10 volts by R1 is 2 ohms. It is 5 amperes. So I1 is 5 amperes. Total current is 10 amperes. Total current flowing in the parallel circuit is 10 amperes, whereas I1 drop in R1 is 5 amperes. Similarly, I2 becomes 5 amps. Why? Because out of 10 amperes, the current flowing in R1 is 5 amps. So 10 minus 5, 5 amperes. So the current flowing in R2 is 5 amps. Otherwise, according to the same relation or Ohm's law, you can apply the formula V is equal to I2 into R2. I2 into R2. So from this, I2 is equal to V by R2. V 10 volts by R2 is 2 ohms. So you will get 5 amperes. 5 amperes. So I1 is 5 and I2 is 5. So if we add these two, 5 plus 5 is equal to 10. Therefore, total current I is equal to I1 plus I2. So total current I is equal to I1 plus I2. I is 10 amps, which is equal to I1 is 5 amps and I2 is also 5 amps. So 5 plus 5, 10. So 10 amps is equal to 10 amps. So this is about parallel circuit. So in series circuit, current flowing in the series circuit is same, whereas voltage drop takes place in series. Whereas in parallel circuit, voltage will be remained same or constant in parallel circuit, whereas current drop takes place in parallel circuit. So this is the main difference between series circuit and parallel circuit. Let me explain one. So this is about series and parallel circuit. So next topic is series parallel circuit. So a combination of series and parallel. So series and parallel circuit. So up to now what we discussed is, first topic is series circuit. Next topic is parallel circuit. Now the combination of both series and parallel. Yeah. So voltage source and he R1. Easily can I explain here. So R1, R2, and R3. Actually, this is a series circuit, right? So I am adding one more resistance. Yeah, R4. Let me say R4. So now the circuit becomes combination of, initially this is a series. Now I am adding one more resistance R4. Now it becomes now combination of series and parallel. So current flowing is initially I. Total current I is flowing up to this node A. Let me say this is node A and B. So up to this node, the current flowing is total current I. Whereas at the node A, the current drop takes place. So the current will be divided into I1 and I2. Why? Because these two resistances, R2 resistance and R4 resistance, becomes parallel. So therefore, the current I will be divided into at node A as I1 and I2. So we know that in parallel circuit, the current will be divided. Current drop takes place. Therefore, at node A, the total current I is dividing into I1 and I2. I1 current is flowing in R4, whereas I2 current is flowing in R2 and as well as R3. The same current I2 is flowing here up to this point, up to the node B. The same I2 is flowing in R2 and R3, whereas here I1 current is flowing in R4 up to the point B or node B, I1. So at node B, I1 plus I2 will be added up and it leads to total current I. Initially the current flowing from higher potential to lower potential. So the total current is I. It was divided into I1 and I2 at node A, and later at node B, I1 and I2 will be added up and total current forms. Okay, so this is the procedure happening in series parallel circuit. So in this circuit, the same current I2 is flowing in R2 and R3 resistances. That means R equivalent here, R equivalent in these two resistances is R equivalent becomes R2 plus R3 resistance. Means we have to add these two resistances. Why? Because the same current I2 is flowing in these two resistances. It is connected in series. Why? Because it is connected in series. Therefore, R equivalent becomes here is R2 plus R3. That means the circuit becomes or modified as like this. So this is initially R1 resistance and this is R4 resistance, and combination of R2 and R3, that is R equivalent. Here the R equivalent is R2 plus R3. So these two resistances I am adding, therefore it becomes R equivalent as. So instead of two resistances, I am writing with only one resistance by adding those two resistances. Now see here the current I, it is dividing into I1 and I2. So that means these two resistances are connected in parallel. These two resistances are connected in parallel. That means R equivalent becomes now, so you have to multiply these two, that is R2 plus R3 into R4 by R2 plus R3 plus R4. So multiply these two resistances and add those two resistances. So that is, later the circuit will be modified as like this. So R equivalent is, so this is the R equivalent and this is the R1. Now the current flowing is same. Why? Because these two becomes series, therefore I will be the same. So series circuit, the current is same, current is flowing is same in the series circuit, therefore in this step, so these two resistances are modified as like this, R equivalent. So now at last the circuit becomes as total resistance R equivalent. So we will get R equivalent is. So for this combination we have to add plus R1. So for this combination you have to add plus R1. So this is the way or procedure for calculating the equivalent resistance. Let me discuss this series parallel circuit by taking an example simply. The same model problem I am considering. Oh, sorry. One ohm, 2 ohm, yeah, again 1 ohm, yeah, 3 ohm. So this is the combination of series and parallel circuit. The total current I is flowing initially, and at node A the current is dividing as I1 and I2. The same I2 current is flowing in these two resistances. That means we have to add these two resistances. So 1 plus 3. 1 plus 3 becomes, why? Because it is series circuit. So 1 plus 3 becomes 4. So modify this circuit as like this. So the remaining circuit will be same, 10 volts, 1 ohm, 2 ohm as it is, and 1 plus 3 becomes, it is 4 ohms. So the current flowing is I1, and the current flowing in 4 ohms is I2. The I2 current is same. So 1 plus 3 is 4. Since these two resistors are connected in series, so the circuit becomes or modified as like this. Now 2 ohms and 4 ohms. See here the current is dividing here, whereas the same current is flowing in these two resistances. Therefore, we are added these two resistances. Whereas in this case, two different currents are flowing, I1 and I2. I1 is flowing in 2 ohms and I2 is flowing in 4 ohms. Two different currents are entering into two different resistances. Therefore, these two becomes parallel. So apply the formula. R equivalent is, initially we have done here, R equivalent is 1 ohm plus 3 ohm, it is 4 ohm. Now in this case, R equivalent means R1 R2 by R1 plus R2, the general formula. So 2 into 4 by 2 plus 4, 2 into 4 by 2 plus 4, it is 8 by 6. Or if you want, you can simplify this as, so 4 by 3. So R equivalent is 4 by 3 ohms. After simplifying these two resistances, R1 R2 by R1 plus R2, that is 2 into 4 by 2 plus 4, 8 by 6. So it is 4 by 3 ohms. So remove these two resistances or modify the resistance as given as. Now this circuit becomes modified as like this. One ohm and the resistance is 4 by 3 ohms. So this, I'm removing these two resistances with the combination, that is R equivalent is 4 by 3 ohms. Now the current is same, the same current is flowing in this. Therefore, add these two resistances. So 4 by 3, so here the R equivalent becomes 4 by 3 plus 1. So 4, so 1 3 is 3, so it is 7 by 3 ohms. So R equivalent is 7 by 3 ohms. So replace these two resistances with equivalent resistance. So R equivalent, at last, the equivalent resistances, by solving all those resistances, series and parallel combination resistances, at last we got the equivalent resistance as 7 by 3 ohms. So total voltage is 10 volts and total resistance or equivalent resistance as 7 by 3 ohms. So from this, you have to calculate current I. According to Ohm's law, we know V is directly proportional to I. So V is equal to Ri. So I is equal to V by R equivalent. So V means 10 volts. 10 volts by R equivalent is 7 by 3 ohms. So this is the current. So in this way, we have to solve the problem. So in this way, you have to solve the given problem. Either is series circuit or parallel circuit or series parallel circuit. So I hope everyone understood the concept of the differences between series parallel and series parallel resistances. So in this way, you have to solve the problem. I hope everyone understood the concept. So hereby you can easily identify or recognize the differences between series and parallel resistances. Thank you. Thank you very much.